This video is going to be on the arc length and sector of circles. And so we're going to start out with the fact that the circumference is equal to 2 pi r, and the area of a circle is pi r squared. I'm sure you remember this from your geometry days. So whenever we're doing arc length and we're given a measure in degrees, we're just going to divide that measure of degrees by 360 before multiplying it by 2 pi r. And when we want the area of a sector, we're going to do the same thing. Take the degree measure, divide by 360, because there are 360 degrees in a circle, and multiply it by pi r squared. So let's say that in this case we have a circle, and the central angle is 120 degrees, and the radius is 6 feet. In order to get the arc length from here down to here, I'm going to take 120 divided by 360 times 2 times pi times 6 feet. And when I multiply that all together, we get approximately 12.57 feet. Now, if I was doing the same problem, except for I wanted the area of the sector, the inside, I'm going to do 120, the degree measure, divided by 360 times 2, not 2, times pi times 6 squared. And so the area of the section in red is 37.70 square feet. And that is how we find the arc length or area of a sector if we're working with degrees. We're going to do the same type of problem, but this time instead of giving the central angle in degrees, we're going to give the central angle in radians. So when we're doing arc length in radian, we're going to do theta, and because around the entire circle is 2 pi, we're going to have theta over 2 pi times 2 pi r. What happens to this 2 pi and this 2 pi? They cancel, so really we just need theta times the radius if we're talking about theta in radians. And for the area of the sector, we're going to have theta over 2 pi again, because 2 pi is all the way around the circle, times pi r squared. And we can't cancel out the 2, but we can still cross out the pi's. So basically we have theta over 2 times r squared. So in this circle, let's say that this angle is 3 pi over 4. And let's say the radius is 8 inches. So in order to get the arc length, I'm just going to take 3 pi over 4 times 8. And that will give me the distance from A to B. And so the arc length is 18.8 inches. Now for the area inside here, I'm going to do 3 pi over 4 divided by 2 times 8 squared. And that gives me an area of 75.4 square inches. And so those were examples of finding a arc length and area of sectors whether they give the problem in degrees or they give the problems in radians.